But
So you noticed that the curve was less of a sort of exponential curve than we might have feared in those early days.
In some ways, there was never any exponential growth. From the minute I looked at it, there were never any 2 days that had exactly the same growth rate, and they were getting slower. Of course, you could have non-exponential growth where every single day they're getting more than exponential, but the growth was always sub-exponential. So that's the first step.
So because we talk, at least over here, we talk endlessly about the R rate, the reproduction rate, and apparently that began very high, maybe as high as 3, and now is down. We've got it down below 1 in the UK. Intuitively, if there's a high reproduction rate, you should see that exponential curve just going up and up.
No, wait. Okay, so let's just see this. The R0, which is very popular, is a in some ways I think a faulted number. Let me explain why. The rate of growth doesn't depend on R0. It depends on R0 and the time you're infectious. So if you have twice as long infectious and half the R0, you'll get exactly the same growth rate.
Right.
And this is sort of intuitive, but it's not explained, and therefore it seems to me that I would say at the present time, I think R0 became so important because a lot of movies that were very popular talked about R0. Epidemiologists talk about R0, but looking at all the mathematics, you have to specify the time infectious at the same time to have any meaning. And the other problem is that R0 decreases. We don't know why R0 decreases. It could be social distancing. It could be prior immunity. It could be hidden cases.